Have you ever just looked at a bullet train and wondered, how? I mean, how is it even possible for this massive heavy machine to just glide down a track at speeds that are basically touching airplane territory? Well, it's an absolutely incredible feat of engineering. So today, let's pull back the curtain and really get into the science behind this modern marvel. So this is the big question, right? How do these things safely and smoothly blast past 300 kilometers per hour? Because, it's not as simple as just sticking a bigger engine in there. Not at all. It's really about coming up with these incredibly clever engineering solutions to fight back against the basic laws of physics. And just to give you a feel for that number, 320 kilometers an hour, that's nearly 200 miles per hour. At that kind of speed, you're covering the entire length of a football field in like a second. This isn't just fast, this is a monumental engineering challenge. Okay, so before we can really appreciate the brilliant solutions, we have to understand the problems. To get anything to move this fast, engineers first had to look at three major physical forces that were basically working against them every single inch of the way. And here they are, our three main villains. First, you've got friction, that constant grinding force just trying to slow the train down. Then there's air resistance, which is like hitting a relentless wall of air that just gets stronger and stronger the faster you go. And finally, vibration, the sneaky saboteur that threatens to shake the whole thing apart. So how in the world did they beat these guys? Well, this next part is all about pure human ingenuity. Let's break down exactly how engineers took on each of these physical puzzles one by one and won. All right, first up, friction. Look, even on a super smooth track, you've got the immense weight of the train just pressing down on the wheels. At low speeds, it's manageable. But once you ramp up to high speeds, that friction can generate incredible heat and, worse, a ton of instability. And the solution? It isn't some crazy sci-fi tech, it's just pure, beautiful precision. We're talking about rails that are welded together into these long, continuous, seamless ribbons of steel. This completely gets rid of that classic clack-clack sound, and the wheels themselves are machined to be almost perfectly round. It's all about making that point of contact as small and as smooth as possible, so the train can practically glide. Okay, next problem, air resistance. See, when you're moving at 300 kilometers per hour, the air doesn't just get out of the way. It bunches up in front of you, creating this immense pressure. It's kind of like trying to run full speed through a swimming pool. The train literally has to punch a hole through the atmosphere. And that is exactly why bullet trains have that iconic, sleek look. That long, pointy nose isn't just for show. It's an absolute masterpiece of aerodynamics. It's designed to slice through the air with the least possible drag, a lot like the nose cone on a fighter jet. And finally, we get to vibration. Now, even with perfectly engineered tracks, tiny imperfections are always going to be there. At high speeds, these little minuscule bumps get magnified into some pretty violent jolts. That can make the ride really uncomfortable and, more importantly, totally unsafe. It could even derail the train. So the solution here is this amazing technology you can't even see, but you can definitely feel it. Or actually, you can't feel it. We're not just talking about regular shock absorbers. These are advanced active suspension systems. They use sensors and computers to instantly detect vibrations and then counteract them, absorbing all those shocks. They keep the train car so perfectly stable, you could probably balance a coin on its edge while going full speed. It's incredible. So all this theory is great, right? But where can we actually see all of this genius engineering at work in the real world? Well, for that, we have to look at one of the most legendary transportation systems on the planet. We are talking, of course, about Japan's Shinkansen, which most of us just know as the bullet train. It was the original high-speed rail network, and it is the perfect real-world case study of all these principles working together in perfect harmony. And get this date, 1964. The Shinkansen has been mastering high-speed travel for decades. This wasn't something that just happened recently. This was a truly pioneering achievement that basically set the standard for the entire world. But let's be real. Speed doesn't mean a thing without safety. And this, right here, is where the Shinkansen's engineering truly shines. Over its entire history, carrying billions of passengers, the network has a near-perfect safety record. It's not just fast, it's phenomenally safe. And that's the ultimate proof of its design. So we've looked at the obstacles, we've looked at the solutions. What's the big idea here? What's the main thing you should walk away with from all this? The key thing to remember is that it's not just one single invention. It's more like a symphony of different fields. You've got precision engineering, you've got advanced aerodynamics, and you've got intelligent track design, all working together to basically shrink huge distances and connect people in a way that was never possible before. And just think about that for a second. This incredible innovation is over 50 years old. It really makes you wonder, doesn't it? If this is what we could pull off back then by conquering friction, air, and vibration, what new physical barriers are we going to engineer our way past next? What do you think the